Yeah, now let's solve this problem. The tangent to the curve at AB is parallel to the line joining the points. So we can just draw some random graph at a point AB. If the tangent is drawn, it is parallel to line joining two other points, which are 0, 3 by 2 and 1 by 2, 2. So basically the derivative at P should be equal to slope of this. But to find the derivative, they have not given y as a function of x. So it would be more easy to find out dx by dy instead of dy by dx. So instead of differentiating with respect to x, if you differentiate with respect to y, this dy by dy will become 1. Here you'll get dx by dy. And here sin y, you'll get derivative as cos y. So from here, dx by dy is 1 minus cos y. And therefore, what would be dy by dx? The reciprocal of this 1 by 1 minus cos y. So what will be the slope of the tangent at AB? Dy by dx at a comma b, if you are writing, that should be equal to 1 by 1 minus cos of, you have to put the y coordinate as b. And this should be equal to slope of line joining these 2 points. What is the slope of this? Difference in y coordinates is 2 minus 3 by 2. By difference in x coordinates is half minus 0. So this will give us 1 by 2 by 1 by 2, which is again 1. So equate this with 1. So this will give us 1 minus cos b is 1. Cos b is 0. That means b has to be pi by 2. And once you get the value of b as pi by 2, how do you get the value of a? A comma b lies on the curve. So we can just use the condition a comma b lies on the curve y equal to x plus sine y. So if you put this b value as pi by 2, so first we say b is a plus sine b because ab satisfies this, and b is pi by 2. So pi by 2 is equal to a plus sine pi by 2. And from here you will get a value as pi by 2 minus 1. A is pi by 2 minus 1. So, and what was b value that you got? Pi by 2. So from here, how do you relate them? So what do you get when you subtract these two? B minus A is 1. So which option will satisfy this? You can take third option, mod of B minus A equal to 1 as the answer. Option 3 is the answer. So let me show the next question. All of you try the 10th one. The equation of normal to the curve at x equal to 0. So we have y equal to 1 plus x power 2y plus cos square of sine inverse x. We have to find the normal at x equal to 0. So first for x equal to 0, let us find out y value. So y would be equal to 1 plus 0 power 2y plus cos square of sine inverse 0. So this is same as y equal to 1 power 2y is 1 only, and sine inverse 0 is 0, cos 0 is 1. So you'll get 1 here. So y equal to 2. That means at the point 0, 2, we have to find the normal. So the point where you have to find the normal is nothing but 0, 2. Now, before that, we need to find out even the slope of the normal, for which we have to use differentiation. So what I'll do is, let us assume that the first one is u and the second one is v. So you can write the derivative in the form of y equal to u plus v, where u is 1 plus x power 2y and v is cos square of sine inverse x. So to make the derivative easier, I'll do separate derivative. So when I assume like this, what will be dy by dx? Same as du by dx plus dv by dx. So we can individually find out the values of du by dx and dv by dx, later add them to get dy by dx. So we'll write u equal to 1 plus x power 2y. I have to do separate derivative because for this I have to use logarithmic differentiation. And when do we use logarithmic differentiation? Whenever you have function power function. So apply log. So log u base c is equal to log of 1 plus x power 2y. Now using the properties of logarithm, 2y multiplies and you'll get 2y into log of 1 plus x base e. Then you can differentiate both sides. Log u will have a derivative 1 by u du by dx. And the right hand side, you can apply product rule. So 2 into y times of what is the derivative of log 1 by 1 plus x. Plus then log of 1 plus x into derivative of y is again dy by dx. So therefore, what is the value of du by dx? It is 2u into u is nothing but again 1 plus x power 2y, right? That 2 into 1 plus x power 2y into y by 1 plus x plus log of 1 plus x dy by dx. This is du by dx. So if you want du by dx at 0, 1, for example, if you want the derivative du by dx at 0, 1, you can also write x equal to 0, y equal to 1. This will become 2 into 1 plus 0 power 1. So that will be 1. Into here you put y as 1, x as 0, you will again get 1. And here if you put x equal to 0, you'll get log 1, 0, 0 and anything is 0. So you'll actually get this value as 2. And when you consider V function, what is V function? It is cos square sin inverse x. And this is same as writing cos of sin inverse x whole square. And we also have a property that sin inverse x can be written as cos inverse under root 1 minus x square. Using that, you can actually remove cos and cos inverse. They'll cancel out. Then root of 1 minus x square whole square will become 1 minus x square. So then dv by dx would give you minus 2x. And once you know this, what the derivative for this at x equal to 0, it is 0 only. So knowing these two, what do you get when you add both the derivatives? You'll get 2. So if you go back, what was dy by dx value? It was the sum of these two. The first one is at 0, 2 if I ask you. The first derivative is 2, second derivative is 0. So 2 is the answer. And if this is the tangent slope, the normal slope will be minus 1 by tangent slope. So what is the normal equation? So the normal is therefore y minus 2 equal to slope into x minus 0. So just simplify this, you'll get x plus 2y equal to 4, I think. Yeah, so this will simplify to give you x plus 2y equal to 4, which is fourth option. So this is again simple. Which of the following points lies on the tangent at 1, 0? So first find the slope of the tangent at 1, 0 using derivative. So x power 4 e power y plus 2 times root of y plus 1 equal to 3. This can be taken as an implicit function. So dy by dx, you can use the formula minus of dou f by dou x by dou f by dou y. Because what is an implicit function? Basically something of the form f of x comma y equal to c is called implicit function. It is something similar only. So we can use this so that we can easily find derivative. Option B you are getting. Let me check the answer. 11. So yeah, 2 is correct answer. Yes. Second option is right. Okay, so if I have to find dou f by dou x, we'll treat y as constant. So e power y will be taken constant and x power 4 differentiation is 4x cube. In the second term, we'll treat y as a constant, so I'll take derivative 0. Similarly, when I write dou f by dou y, we'll treat y as variable, x as constant. So x power 4 will be constant, e power y differentiation is e power y. In the second part, we get 2 into derivative of root of this is 1 by 2 root y plus 1. So this is same as minus of, what do you get here? E power y into 4x cube plus 0 we got up here. So e power y into 4x cube by x power 4 into e power y plus 1 by root of y plus 1. And you need to find out the tangent at 1, 0. So find the derivative at 1, 0 to get the tangent slope. So dy by dx at 1, 0, when I write, put x as 1, y as 0. So that would give e power 0 into 4 into 0 by, again, whatever is there here, it doesn't matter. Anyway, it will become 0 only. 1 by root of 1 plus 0. So you'll get the value as 0 itself. So what will be the equation? So tangent at 1, 0 is y minus y1. So y minus 0 equal to slope into x minus 1. So you'll get, I made any mistake in calculation. What did they ask you? Tangent at 1, 0 only. No? Okay. Y minus 0 equal to slope into x minus 1. So let me check the slope. The point was x equal to 1, sorry. So I substituted it wrong. So when I do the calculation part, what is the slope? We are putting x as 1, y as 0. So minus of e power 0 into x as 1, it is 4 here. Similarly, here x is 1, y is 0. So 1 into e power 0. And 1 by 1 you will get. So I think this is minus 4 by 2. So minus 2 you are getting. So write minus 2 here. The equation will be y equal to minus 2x plus 2 or 2x plus y equal to 2. So which point will satisfy this? Minus 2 comma 6 satisfies. So that should be the answer. So second option is therefore right. So we have a random quadratic given ax
Yes,
square
sir.
x plus c. You got it? Yeah. So if the curve passes through 1, 2 means 1, 2 is somewhere on the curve. And then the tangent at origin to the curve at the point 0, 0, we'll name it as O itself. So it passes through some P, and at origin, the tangent to the curve is y equal to x. What are ABC? So since you have three unknowns, you need three equations. So first substitute 1, 2 in the curve, because 1, 2 is a point on the curve, 1, 2 satisfies it. So you can put x equal to 1, y equal to 2 equal to a into 1 square plus b into 1 plus c. So this will give you a plus b plus c equal to as equation 1. Then the second criteria, the curve also passes through origin. So 0, 0 lies on the curve. So if the point 0, 0 lies on the curve, put x equal to y equal to 0. You get 0 equal to 0 plus c. So c will be 0. Second condition. And the third condition is because this line is a tangent, derivative at this point should be slope of this line. So if you write dy by dx for the curve, differentiation of this is 2ax plus b. At the point 0, 0, so dy by dx at 0, 0, when I write down, that should be, when you put x as 0, it will be b. And this is 1 because you already know the line. So once you know that b is 1 and c is 0, so b is 1, c is 0, put this in the first equation, a plus b plus c equal to 2. So if you put it here, a plus 1 plus 0 equal to 2. So a will be 1. So a is 1, b is 1, and c is 0. So second option is the right answer. So this was quite simple. Just time taking, but easy. Yes, all of you try this. Angle made by the tangent at x0, y0 on the curve is given, and the curve is given in parametric form. What is y0? So if the angle made by the tangent is with positive axis pi by 3, what does it mean? So if the angle made is theta, and what is the slope? Tan theta. And because it makes pi by 3, so tan pi by 3 is the slope of the tangent. So this m is the slope of the tangent at x0, y0. This is slope of tangent, TGT in short, at x0, y0. How do you find that? So let us find out the derivative using parametric differentiation. So we have x value as 12 into t plus sine t cos t. So what is dx by dt from here? 12 into the derivative of t will be 1. And actually this sine t cos t, you can simplify it. You can write that as, if you open the brackets otherwise. So before only, I'll just open the bracket before differentiating only. So let me write that as x equal to 12t plus 12 into sine t cos t. I can write 6 into 2 sine t cos t, which is sine 2t. Let us write like this. Then dx by dt would be equal to, differentiation of 12t is 12. And this is 6 into sine has a derivative cos 2t. 2t has a derivative 2. So this is the value of dx by dt. So that is 12 is common into 1 plus cos 2t. And 1 plus cos 2t from trigonometry, we know it is 2 cos square t. So this is 24 cos square t. Similarly, let us find dy by dt. So what is the value of y given? 12 into 1 plus sine t whole square. So what will be the derivative dy by dt? 12 into, here the derivative of x power n is nx power n minus 1. So 2 into 1 plus sine t power 1. Multiplied with, by chain rule, you have differentiate even 1 plus sine t also. 1 will have a derivative 0, sine t will have a derivative cos t. So this is again 12 into 2, 24 into 1 plus sine t into cos t. So if you divide them, you will get dy by dx. dy by dt and dx by dt are known. So dy by dx can be written as dy by dt divided by dx by dt. So that is same as, so what is the value of dy by dt? Is 24 into 1 plus sine t cos t divided by what is dx by dt? 24 cos square t. So 24 cancels out, and this will cancel and give you 1 plus sine t by cos t. This is dy by dx. So, but they ask you derivative at some x0, y0. They didn't give t value. They've not given us t value. So how do you do it? So if x0, y0 lies on the curve, x0, y0 lies on the curve. So you can say x0 will be equal to 12 into t plus sine t cos t. And y naught is equal to, what is the y coordinate given already? 12 into 1 plus sin t whole square. You already know this. So you just see if you can convert this in terms of x naught and y naught. They actually asked us to find out value of y naught. So is it possible to convert this in terms of y naught? So they already gave the slope. So what is the slope given? Root 3. So I think you can just straight away equate with root 3 here. So when you equate with root 3, what will be the value of sin t or cos t you can find from this? Like I think you can simplify it in terms of tan or anything to find t value. And once you know t value, you can substitute here, you will get y naught value. Because they asked you y naught only, you can find out y naught using this, but you have to know t from here. So solve this for t and do it further. So this means secant t plus tan t is root 3. And in trigonometry, we know that if secant plus tan is known, what is secant minus tan? It's reciprocal because you know that the product is 1. Secant plus tan into secant minus tan is secant square minus tan square, which is 1. So this would be 1 by root 3. So you add them, you'll get 2 secant t equal to root 3 plus 1 by root 3. So 4 by root 3. So secant t will be equal to 2 by root 3. So cos t is root 3 by 2. That means what is the value of t here? 30 degrees. And put that value here, you'll get 12 into 1 plus sin 30. What is sin 30 degrees? Root 3 by 2 or 1 by 2? 1 by 2. So sin 30 would be half whole square. So 12 into 9 by 4. So that will give you 27 as an answer. But you have this in the options. Yeah, 27 is there. So C option is correct.